Before I observe any power cut, let's finish our, I think I should start my discussion. If you are facing any difficulty, let me know. I think we should start with a problem shared by the students. हा कोणी शेअर केला होता प्रॉब्लेम? आहेत का ते स्टुडंट्स? Am I audible, students? Am I audible?
Yes, sir.
Yes, sir.
हा प्रॉब्लेम ज्यांनी शेअर केलेला तो आहेत का? विद्यार्थी आहेत का ते? Okay. See, in the yesterday discussion, we had an ordinary differential equation. Today, we'll focus on partial differential equation, how to find the solution. Now, basically, in a partial differential equation, we learn there are three techniques. One is called as a Laplace equation, second is the Poisson's equation, third is the parabolic equation. In examination, generally, they will not mention like a Laplace equation. Here it is mentioned, right? You can see that it is mentioned a Laplace equation. Can you follow the cursor? Is it visible to all of you? I think now it's visible, right? Oh. So let us try to understand what's this problem statement. And specifically, the students have shared it from last year examination, if I'm not wrong. So given values, u is a function of x and y. U is a function of x and y on the boundaries of a square is as follows. Evaluate the function uxy, satisfying the Laplace equation. Now, most of the time, students, Laplace equation may not be mentioned like this word, what I'm saying, but they will provide you this equation. That equation itself is the Laplace equation, right? You can see that explicit elliptic solution, Laplace equation, can be represented like del square u upon del x square plus del square u upon del y square is equal to 0, which can be also represented in another way. So this is all the Laplace notation. We are talking about C. The equation can be represented like del square u upon del x square, del square u upon del y square. The Laplace and the Poissons are generally used where the time function is absent. We don't have a time function. So it's a function of x direction and the y direction, right? So this is a Laplace function. If del square u upon del x square plus del square u upon del y square, if it is equal to 0, then it's called as the Laplace equation. Otherwise, del square u upon del x square plus del square u upon del y square, if it is equal to function of f xy, then this is called as Poisson's equation. The notations, you can find out different notation in examination, maybe in questions. We can represent this term as uxx square and this term as uyy square is equal to 0. This is again known as Laplace equation. The same can be represented like del square u is equal to 0. So where del square is nothing but del square upon del x square plus del square upon del y square. But this is what the interpretation. And if I'm adding u, that means that you are taking second order differentiation of u, which is the function xy, right? You can stop me anywhere if you are not able to understand, then you can stop me. Let us come to the question. Hope you understood the difference between, and whenever the function is a function of time, you have to use a parabolic. Here you can see that it's not a function of time, it's only function of direction, right? But with the time present in the problem statement, that means what you have to use parabolic equation. That is what we learn in theory class, right? So let's try to solve this numerical. In this numerical, what is given? Solution. In a solution, let us write what is given. Can you help me out to find out what's given in the problem statement? The first is the Laplace equations. Okay? So Laplace equation is given, and that Laplace equation is being represented del square u is equal to 0. Sometimes this segment or the words are not given, so directly equation is given that you have to understand this is the Laplace equation. Then the boundary conditions are given for the top 1000, for the bottom 500, for the left 2000, and right 500, and the grid system that we are having 3 by 3. Okay, so that is what the information we have. So let us prepare a grid. It has an x-axis and the y-axis. In this x and y-axis, we have to place a square because it's a square, no? A square as a follow. So it is going to be a square. Now square is 3 by 3, means what? Lower left corner, it is 0, 0, and upper right corner, it is 3 by 3. So this is what the grid system. Now it is a 3 by 3 grid point. So we have to divide this entire x-axis and the y-axis with a step size 1. So I will divide this like this is going to be 1, and this is second. And here also we will have equal step size on y-axis. So this is your grid. Okay. Now in this grid, we will write this point. This point is nothing but let's say that u1, this is u2, this is u3, and this one is u4, right? And the grid distance or distance between grid point is 1 along x-axis, along y-axis it is 1. Even though it is not mentioned, but this is a 3 by 3 grid point, so you can find out the grid points here. Okay. Now we have to find out the value of u1, u2, u3, u4. Right? But for that, what additional information we have? You can see that the top layer, it is subjected to the 1000, bottom is subjected to the 500, left is subjected to 2000, and the right is subjected to the 500. So we got all this grid system. And for this grid system, now we have to find out a solution. Finding the solution using a Laplace equation does mean you have to find out u1, u2, u3, u4. So let us find that. Okay. So how to find this? First of all, we should know the equation for u. What's the equation for u? Can you tell me, students? Anyone? What's the equation for u? Let us say that this is the u point that we have to find out. This is u right, this is u up, this is u down, and this is u left. Can you tell me the formula for u? Please, first.
Yes, sir.
Yeah, 1 upon 4
4
in bracket
into in bracket ur plus
u
u left u up plus u down.
U up plus u down. So you have to take a simple summation of all these terminals. Okay. So what is this basically? So let us try to understand what is this and how we can use this formula to find the value of u1, u2, u3, u4. This all these things we have discussed in theory class, but again as a part of revision. So 1 for u1. We are going to find out u1, this value. So for the students, the center value is u1, right? This u is nothing but the center value. This is nothing but the center value. So u1 is the center value. For u1, I can write or I can prepare a diagram plus sign. Okay. So where u1 will be a center value that we have to find out, right? So for the u1, what is the right value? Please, students, for u1, I'll consider this grid, no?
u2.
Plus sign.
u2.
Try to understand. This is what I'm considering. Okay. So here it is u2. Here u4. On this side it is
2000.
and bottom it is 500. So once we are having this, can we write u1 is equal to 1 by 4 constant 1 by 4 U2 plus U4 plus 2000 plus 500. Let us simplify this equation. 4U1 U2 plus U4 plus 2000 plus 500. Okay. Rewrite this equation for U1. Let us say that 4U1 minus U2 plus U4. Oh, it should be minus, sorry. It is U2 minus U4 minus 2000 minus 500 is equal to 0. So that is your equation number 1. Okay, from U1. Any difficulty, any questions, students, by the time?
No, sir.
Now, we will write for U2. For U2. For U2. So we will prepare a grid again for U2. So this is U2. Now, from this, can you tell me what's top, up value, right value, left value, and bottom value? U3, U1, 500, 500, right? So let us write these values. It is U3, 500. So 500. And what's this value?
U1.
U1, right? Correct. Now let us write for U2. So U2 is equal to 1 by 4. And you have to take a summation of all these terminals. That's so simple. U1, U3 plus 500 plus 500. Right? Rearrange this equation and write in the form of this. 4U2 is equal to U1 plus U3 plus 500 plus 500. Right? So we'll write minus U1 plus 4U2 minus U3 minus, okay, 500, 1000. You can write. That is the equation is equal to 0. That's the equation number 2. And here also we can write now 4U1 minus U2 minus U4 minus 2500. So I'll write this as an equation 1. Okay. Now similarly, we are going to write for U3. So third, for U3, prepare a plus sign considering U3 as a center value. So that is going to be U3. So for U3, here it is a 500. Correct me, students, if I'm going if I'm writing some wrong values here. 1000. On right, it is U4. Right? Bottom, U2. Right? So let's write for U3. U3 is equal to 1 by 4. U2 plus U4 plus 1000 plus 500. So 4U3 is equal to U2 plus U4 plus 1500. Now simplifying this equation, like U2 minus U2, I'm taking all these terms on the other side, plus 4U3 minus U4 minus 1500 is equal to 0. So this is equation number 3. Similarly, we are writing the equation for U4. The fourth is for U4. So for U4, so U4 is the center value, and for this U4, it's a 1000. Here it is 2000, U3, and U1, right? So let us write for U4. U4 is equal to 1 by 4, U1 plus U3 plus 1000 plus 2000. Right? Simplifying. 4U4 is equal to U1 plus U3 plus 3000. So let's write minus U1 minus U3 plus 4U4 minus, we will keep this constant on the other side. That will be better. We will keep this as an example here also. Okay, I'll modify this equation. That will be better. Because we have to write a simultaneous equation, right? 4U3 minus U4 is equal to 1500. So let's say that this is equation number 3. And this is equation number 4. Similarly, I'll modify or rewrite, not modify, rewriting this. U1 plus 4U2 minus U3 is equal to 1000. That is equation 2. Just erase it. And similarly, we'll write this also. For U1 minus U2 minus U4 is equal to 2500. We got all these equations, 4 equations. Any doubt, students, to get the 4 equations? Yes, students? Any question? I'll collect all these 4 equations. I'll try to write for U1, U2, U3, U4. Okay, these are the 4 equations. So let us write. Let's write 4 simultaneous equations. Help me out to write the simultaneous equations, students. 4U1 minus U2 plus 0U3, because U3 is not present, minus U4 is equal to, can I write in this way? Because I want all these terms. Hello, students.
Yes,
Hello?
sir. Yes, sir.
Yeah. Tell me second equation.
Minus
second
U1
Minus U1
minus
plus 4U2
4U2
minus U3
minus U3.
plus 0U4
Correct.
is equal to 1000.
Good. Next. Next. For U3, we got an equation.
0U1
0U1
minus U2
minus U2
plus 4U3
U4 is equal to 1500. Correct. The last equation is now visible to all of us. We'll write minus U1 minus, plus 0U2 minus U3 plus 4U4 is equal to 3000. Okay. These are the 4 simultaneous equations. Now, hereafter, the unknowns are U1, U2, U3, U4. So we are having 4 unknowns, right? And 4 equations. Okay. Either you can use Gauss elimination to solve this equation, or you can use Gauss. Any of this method you can use. Okay. So 4 by 4, you have to solve by using Gauss elimination or Gauss error. But if you are using a Gauss elimination, this is my personal opinion. You can use Gauss elimination. Some books, they are using Gauss elimination with partial pure. My recommendation is to go for Gauss error. It's a very easy method. You can find out. And see, students, the question which is asked for the examination is of 10 marks. So 10 marks does means, see, this is very simple. To get the equation is very simple part. So you will get the half of the mark to get the simultaneous equation, right? There should not be any challenge to write this equation using Poisson Laplace, right? But the challenge is to get the value of u1, u2, u3, u4. And here, the remaining marks are allotted for Gauss-Seidel or Gauss elimination. So that also marks will be there for the steps. And few marks will be for representing your final answers. Right? So here I'm using Gauss-Seidel. Let us use Gauss-Seidel. Gauss-Seidel. It's a kind of revision for the Gauss-Seidel as well, students. Those who are attending this first time. In a Gauss-Seidel, first of all, these equations, what's the first step in a Gauss-Seidel, students? Can you tell me anyone? We got on 4 equations
Pi
or 3
what
equations? 3
element?
unknown. Uh-huh.
Pi what
Yes,
element?
come. Yeah, you have to first check that the diagonal elements are maximum. And fortunately, for Poisson's Laplace, we always get diagonal element as a maximum. Right? So Gauss-Seidel says that you have to check this condition all the time. Summation of all diagonal elements must be greater than equal to summation of remaining elements. Right? Mode of. So this is the condition. If this condition is being satisfied by the set of equation, then we can apply the Gauss-Seidel. If not, then you have to switch the equations. Okay, ensuring that this condition will get satisfied. In other words, it is not always in the theory class practical sections also I told you, it is not always mandatory to have a maximum values along the diagonal. In some cases, you have to compromise the maximum value, but ensure that this condition is satisfied. Okay. So now in this case, equation 1, 2, 3, 4, the diagonal elements are maximum as compared to the others, right? So it is already in maxima diagonal. So what I'm doing, using equation, let us say that A, equation B, equation C, equation D. So I'll write from equation A. So what I'll write for Gauss-Seidel, no? I'll write for U1 because I'll consider this as a maximum element. I'll write U1 is equal to now 1 by 4. I have to write an equation for U1, 1 by 4, 2500 plus U2 plus U4. Any question? Any doubt? Any questions, students? Hello.
No, sir.
Okay. Now, similarly, we can write from B. We will write now for U2. U2 is equal to 1 by 4, 1000 plus U1 plus U3. From C, we can write for U3. U3 is equal to 1 by 4 in bracket 1500 plus U2 plus U4. And from B, we will write for U4. U4 is equal to 1 by 4, 3000 plus U1 plus U3. So we got all these equations. Now we have to apply the Gauss-Seidel. How to apply this Gauss-Seidel? Tell me, students. Now we got all these 4 equations. We have to apply Gauss-Seidel. Tell me. Hello. I request all of you students, please respond. It's a revision. I'm not teaching you right now. It's a revision. You have to tell me. Otherwise, tomorrow is the examination. Still, you are not able to understand or you are not able to answer the question like what's the consider? What's the next step?
So put the equation in calci.
Yeah, first is you have to write, put your equation in calci. But before that, okay, you have to do all these things. But while doing that in a calci, I'll consider this as u1 as a because I need 4 parameters. No. So what variables we have in calci? A, B, C, D. We got an A, B, C, D, right? So can I write here U, use different color. U1 is A, right? U1 is A, U2 is B, U3 is C, and U4 is D. Can I use this one?
Yes, sir.
Now I will have a modification like U1 is A, here U2 is B, and U4 is D. Okay, D. Then here U3 is C, here U2 is B, and U4 is D. Here you can see that U1 is A and U3 is C. U1 is A, U3 is C. So you can write these equations. Any questions, friends? Any questions? Hello.
सर पण कॅल्शियम टाकले की ते व्हेरिएबल एरर येते.
काय तर
व्हेरिएबल एरर.
एकच मिनिट. सो ही कॅल्शियम मध्ये काय? ओके, मी तुम्हाला सांगतो कसं करायचं कॅल्शियम. So I have to write that equation in the calcium. See, students. You have to write an equation for U1. U1 is what? 1 by 4. So I'll write here. Is it visible? Calcium is visible to all of you?
Yes, sir.
2500 plus U2 is what? Alpha B, right? Plus alpha D over 4. So this is the equation for U1. Is there any problem? Then you have to say cal and substitute the value of B, D, and you'll get the answer. Is that okay? Similarly,
Yes, sir.
now that will be in a memory now, students. I can recall that equation like this. If I'm writing in second equation for U2, I will write like this. 1000. So calci, use of calci is very important. You should know. Alpha A. And this is the trick we are using. And that makes the solution very simple. Right? So less time. Then calc. You can put in value of A, C, and you'll get the answer. And still, both the equations are in memory. You can see that. This is for AC means what? This equation. And earlier equation BD, that is also in a calculator. So similarly, you can write for U3 and U4. All 4 equations are in a calci, in memory. You can easily access them by navigating, and accordingly you can do the calculation. Any question now? So
No, sir.
next what we are going to do, we are assuming, come on, assuming, or we'll say that let, not assuming, let U1 is equal to 0, U2 is equal to 0, U3 is equal to 0, and U4 is equal to 0. So what are these in our notations? A, B, C, and D. Right? So after this assumption, now we are going to prepare a table. Now I'm not going to explain you the entire calculations. but few calculation together will have a calculation C students U1, U2, U3. Okay, and the accuracy you can consider here, accuracy 0.01. If it is not mentioned, you have to consider this. So for an accuracy, you just keep on checking accuracy. This is for U1, this is for U2, and this is for U3. And let us write values. So this is iteration numbers. Obviously, the first iteration is 0, 0, 0 because we are solving for U1, U2, U3, U4. So that is your iteration number 1. But since we are using Gauss seidel as a secondary method to find the variables, so I'm not writing the iteration 1 and 2. अगर यही क्वेश्चन आपको एग्जाम में पूछा है, solve the following simultaneous equation using Gauss seidel, then you have to show the first 2 iterations calculations and remaining calculations you have to show in table. This is mandatory. Okay. U1, U2, U3, U4. Then here you're supposed to write U1 old minus U1 new mod. Similarly, U2 old minus U new, U2 new. Similarly, you can write mod of U3 old minus U3 new. And the last one is mod of U4. And you just continue. Okay. So you can write here. Now we have to find out U1. So for us, U1 is what? A, U2 is B, U3 is C, and U4 is D. Now I have to find out U1. So use on calculator. So what's the equation for U1? ये equation है ना U1 के लिए. Hello students.
Yes, sir.
हाँ, so पहले जो assumptions value है 0, 0, 0. All values are 0, 0. So I'm going to put that. What's the value of B? 0.
0.
What's the value of D? 0.
0.
So what's the value we are getting here?
6 to 5.
6 to 5. Okay. Now, जब भी हमें न्यू वैल्यू मिल गई तो पुरानी वैल्यू को क्या करेंगे हम लोग? स्क्रैच करेंगे. ठीक है. नेक्स्ट कौन सा इक्वेशन है? नेक्स्ट कौन सा है? U2. U2 का यही फॉर्मूला है हमने जो सेव किया था. सो U2 का फॉर्मूला में क्या चाहिए? U1, U3. अभी बताओ कौन सा U1 लेंगे हम लोग यहाँ पे?
0 ना सर.
न्यू वाला.
मैंने 0 कट कर दिया ना U1 का वैल्यू.
Okay,
We
sir.
are not going to use that once I get the new value. है ना? ये कट कर लिया ना मैंने, देखा है आपने? इसको कट कर लिया मैंने. Can you see that? बघितलं का
Yes,
कट के
sir.
लिया. भाई U1
Yes,
वैल्यू अवेलेबल नहीं है. You have to use a new value. Right? 6 to 5 and next C. C ची value म्हणजे U3 ची value 0. So what you are getting? 406. 406.5. जब मुझे नया वैल्यू मिल गया तो I had to strike the old one. Similarly, can you find out U3? U3 के लिए now I have to write a formula. बताओ क्या है? 1500 प्लस U2 मतलब अल्फा B प्लस U4 मतलब अल्फा D. इक्वेशन एक बार चेक करो, करेक्ट है. अगर इक्वेशन गड़बड़ हो गई यहाँ पे लिखते वक्त तो पूरा सोल्यूशन इवन दो यू नो द मेथड्स पूरा गलत हो जाएगा. सो कैलकुलेट. नाउ लेट अस कैलकुलेट दिस. U3. What should be the B value now? क्या रहेगी?
406.25.
Yes, 406.5. और नेक्स्ट क्या चाहिए? डी की वैल्यू. डी की वैल्यू क्या रहेगी यहाँ पे?
0.
0. अभी ये आंसर आ गया. क्या आएगी? 476. 476.625. 625. ये नई वैल्यू मिलने के बाद पुरानी वैल्यू क्या करेंगे? हम स्ट्राइक करेंगे. सिमिलरली द नेक्स्ट वन. बताओ नेक्स्ट वैल्यू क्या रहेगी? इक्वेशन 3000 प्लस U1. U1 मतलब A एंड C. अल्फा A प्लस अल्फा C divided by 4. Calculate. What's the A value? 625. And what's the C value? 476.625. ठीक है, देखो निकालो इसको अभी. 1025.4062. 4063 ना. ये नई वैल्यू मिल गई, पुरानी को स्ट्राइक करेंगे. सेकेंड वैल्यू. नाउ जस्ट टेल मी नाउ स्टूडेंट्स, अभी मेरे पास सभी इक्वेशंस है यहाँ पे. बताओ आई कैन गेट दैट इक्वेशन. फिर से हमें टाइप नहीं करनी है वहां पे. कौन सा इक्वेशन? ये है ना U1 के लिए. हेच आहे ना इक्वेशन U1 चं.
Yes, sir. Yes.
कॅल्क्युलेट. आता बी व्हॅल्यू सांगा मला. बी व्हॅल्यू काय असेल?
406.5.
405. ओके. डी व्हॅल्यू काय असणार आहे?
1025.
025.4.
4063. 982.9766. 982.9766. अभी ये नई वैल्यू मिल गई, पुरानी वैल्यू को क्या करेंगे हम लोग? स्ट्राइक करेंगे.
Right.
चलो अभी कौन सा है? U2 निकालना है. U2 का कौन सा इक्वेशन है बताओ? ये U2 है 1000. कैलकुलेट. ये वैल्यू क्या है बताओ? अभी ए की वैल्यू क्या रहेगी?
982.9766.
9766. सी की वैल्यू 476.625. हाँ 614.900614. ये 614.9004. ये नई वैल्यू मिलने के बाद पुरानी वैल्यू क्या करेंगे हम लोग? स्ट्राइक करेंगे. एक लाइन पेंसिल से एक लाइन मारना है. पूरा ऐसा दिखना चाहिए वो वैल्यू एग्जाम. ये हमारा मेथड है स्टूडेंट्स. वी आर यूजिंग दिस मेथड, है ना, टू मिनिमाइज द एरर्स. चलो अभी ऐसे ही सॉल्व करते जाओ. कब तक सॉल्व करना है? ये वैल्यू जो है ना, अनलेस एंड अंटिल यू आर गेटिंग दिस 2 डेसिमल्स रिपीटिंग. एक भी अगर रिपीट हो रहा है ना, ये भी, यू कैन स्टॉप नंबर ऑफ इटरेशंस. कब तक करना है ये? until you are getting this value repeating. For example, एक लास्ट वैल्यू आ रही है. let us assume that maybe 625.03, है ना. तो हम लोग को नेक्स्ट वैल्यू क्या आएगी 8 इटरेशन को? फॉर एग्जांपल यही नहीं आने वाली है. सो यू कैन से दैट 06. 9 में क्या आएगी? 625.08. है ना। अभी देखो ये वैल्यूज है रिपीट हो रही है डेसिमल की, ये तो हो रही है, दैट मीन्स व्हाट, द वैल्यूज इज क्लोजर टू द फाइनल आंसर, सो यू कैन राइट योर आंसर, लाइक यू स्टॉप इटरेशन फॉर दिस, जस्ट कंटिन्यू, अगेन यू हैव टू कंटिन्यू, जब तक वैल्यू रिपीट नहीं हो रही है you have to continue. When you are using Gauss seidel as a secondary method, जेव्हा तुम्ही गॉस सिडल आहे ना सेकंडरी मेथड यूज करता आहात, जिथं कुठलीही कंडिशन दिलेली नाहीये, टर्मिनेशन, किती आयटरेशन सॉल्व्ह करायचे आहेत, काय एरर आहे हे दिलेलं नाहीये, त्या ठिकाणी यू कॅन अप्लाय दिस रूल ऑफ थंब रूल, जिथं जिथं तुमचे व्हॅल्यूज रिपीट व्हायला लागतील तिथं तुम्ही ते इटरेशन थांबवतील. हे एकच झालं, असंच ह्याचं पण रिपीट व्हायला पाहिजे, ह्याची पण रिपीट व्हायला पाहिजे, ह्याची पण रिपीट व्हायला पाहिजे, आणि ज्या मोमेंटला तुमच्या व्हॅल्यूज रिपीट होतील त्या मोमेंटला तुम्ही थांबणं गरजेचं. हे क्लिअर आहेत गोष्टी? हॅलो स्टुडंट्स, लक्षात आलं गॉस सिडल?
Yes, sir.
सो दिस इज व्हेरी सिम्पल, 10 मार्क डन. मॅक्सिमम वेळ आपला हाच ह्याच्यासाठी जातो सोल्युशन, बाकी मेथड सोपी.